Okay, so last lecture we learned about the Spanish collision with the Native American cultures in the New World. And today we're going to learn about what happened after that, particularly in the use of metals, and one metal in particular, silver. All right, so let's talk a little bit about silver. That's got the chemical symbol Ag. It's element 47. Everybody knows it. We used to have coins made out of it. All right, here's some nice examples of native silver. These are crystals of silver, native silver. Got this very interesting herringbone twin pattern. This is from Germany. Here's another way that silver appears. These wires, beautiful wires of silver. This thing is 3 or 4 inches tall, from Germany. All right, so silver has been used for thousands of years as ornaments and utensils, for trade, and increasingly as money. It was first isolated around 3000 BC. Of all the metals, pure silver has the whitest color, the highest optical reflectivity, and the highest thermal and electrical conductivity. We used to use a lot of silver halide in film. It's photosensitive. We don't use much of that anymore. But it has many industrial applications in the modern world, such as in mirrors, electronic products, photography, which used to be the single largest use of silver, not anymore. Silver's catalytic properties make it ideal for use in oxidation reactions. For example, the production of formaldehyde from methanol and air by means of silver screens or silver crystallites. So that's modern material science. We don't need to talk about that. But previously it was mostly used for coins, jewelry, etc. Today it's mostly used for industrial purposes, and it's increasingly used in photovoltaics, that is, solar energy panels. All right, so here we have world silver production in the last decade or so. So here we've got millions of ounces of silver, and here we've got the years. Yeah, we're here. And so you can see that we've produced very close to 1 billion ounces a year now. And if you look at the main places it's coming from, it's 2 places we're going to talk about in this lecture. Mexico is the biggest, and Peru is the second biggest, followed closely by China, Russia, and Chile. All right, so the price of silver, like gold, has varied a lot. It was as high as $50 an ounce in 2011, and now it's about $30 an ounce or so. So let's talk first about Cerro Rico de Potosí. This is in Bolivia. This is here on our map. And here is an old sketch of what the mountain looked like and the town around it. So this was the richest silver mine in the world. Indian Diego Hualpa discovered it in 1544. So the story is he was chasing llamas up the side of the mountain. He made a camp for the night and a fire. In the morning, he was surprised to see that the rock underneath the fire had melted and formed a small rivulet of silver. So in his native language, the Quechua language, it is Orco Potochi, the hill where silver flows, and that's where the word Potosi comes from. It lies at 15,000 feet elevation. It's still the world's highest city with a population of more than 100,000 people. Now, Cerro Rico means rich hill, and that is an extremely good name for it. The Spaniards to this day use the phrase, "It's a Potosi" for anything superlatively wealthy. So Charles V sort of set that going. He was the king of Spain during the time that Potosi was discovered. And he said, "I am rich Potosi, the treasure of the world and the envy of kings." By 1572, it was the Western world's most populous city, with 120,000 inhabitants, more than London, Paris, or Madrid. It's hard to believe that the largest city in the world was also the highest, 15,000 feet, but it was. So silver was a key to the Spanish Empire. The Spanish Colonial in the New World produced somewhere between 30,000 to 60,000 tons of silver since the 1550s. The peak was in 1580 with 13 million ounces produced. And overall, the Spanish were just as interested in gold, if not more so than silver. But the reality was their colonial empire was silver rich and gold poor. So the production of precious metals in the New World by the Spanish colonial mines was 98% silver and 2% gold. And by 1560, silver from Peru and New Spain, that's what Mexico was called back then, were the most important imports to Spain. So the silver from Potosí and other Peru mines way up in the mountains of the Andes had to be taken down to the coast to be shipped by boat. So there would be typically caravans of 2,000 llamas and 1,000 Indians carrying silver down to the port of Arica and then mercury back up to Potosí. We'll learn why they wanted to bring mercury back a little bit later. So here you've got a woodcut drawing of the llama caravans carrying loads of silver on them from the 1500s. So just to show you where it is, so Potosí's over here in Bolivia, Arica's over here on the coast now in Chile. And, you know, this is from Google Earth. These are 2 ways to walk from Potosí to Arica, but it'll take you a while. So Potosí was a key to globalization. So it's hard to remember that the world was not very well connected at that time, but it was getting connected because of trade. So from the 1550s, Potosí was at the center of the first international exchange and the first truly globalized economic and trading network. In effect, the silver that Potosí and to a lesser extent New Spain produced created the first global currency, which was the silver pieces of 8, each with the mark P for the Potosí Mint, which was established in 1574. So here you can see that global trade. This is a Spanish galleon in China, and the Chinese were very interested in trading their riches, silks and spices, for the silver. All right, so here is a piece of 8. It's a little beat up, but here we can see what it looks like. So you'll notice this tic-tac-toe design here. These 2 upright pillars represent the pillars of Hercules. The waves below, this is the Atlantic Ocean. So starting at around here in the 10 o'clock position, that P is for Potosí. And the next is the denomination. This is 8 reals. And then the assayer's name. Somebody had to guarantee that this was not some debased currency, that it was silver. And this was for a guy who ran the mint, the Potosí Mint, in the 1600s. There's another E down here, but it means the same thing as that one. The number 77 refers to the year, so this means 1677. And in the center, you can see it. This says Plus CVL Ultra, which stands for Plus Ultra, meaning there's more beyond the Pillars of Hercules, and that is very definitely true. On the reverse side, you see the Crusaders' cross here, and with the lions and castles. They're a little bit beat up here, but there's definitely a castle and lions there, representing the early Spanish kingdoms of Leon and Castile. And at the bottom is also 77, the date. Coins that were minted in the 1700s will have 3 digits. That is like 737 for 1737. So anyway, next time you run across a piece of 8, you'll understand what all those things mean. All right, so here is the way the silver trade went to China. So the silver was transported from Arica, which is down here, up to Acapulco, and then it was sent west on the trade winds over to the Philippines, and then the Philippines were part of the Spanish Empire, and then ships would go out to Canton and Moe to trade and back, and then this trading material would be brought all the way back to Acapulco on the westerlies. So this was an amazing trade. And then what was brought back from China was transported over New Spain to Veracruz, or a port on the Gulf of Mexico, which was then shipped back to Spain. So at this time, the crown claimed the royal fifth of silver. So this is a word, where the word royalty comes from. You know, when somebody gets something, you know, royalties on a book or whatever, sort of comes from this idea that the crown got 20% of anything that was acquired. So silk and spices from China and the royal fifth of silver was carried overland and sent to Havana, via Havana to Spain. The relative value of gold to silver was 10-1, but the huge increase in silver supply that was found in the New World increased that to 100-1. Now it's about 70-1, the value of gold to silver. Now all of this silver coming into Spain created a lot of inflation. So it crippled Spanish industry and at the same time stimulated the growth of industry in Northern Europe. So it had a huge effect on the development of Europe. And silver molded the social and political climate of Spain's Renaissance, built the famed Spanish Armada, and bankrolled Spanish wars against the Turks, Italians, Flemish, French, and English. So here is a Bolivian coin from 1853, but it just captures Potosí. So this was after Bolivian independence, but Potosí figures very large in the history of the Spanish viceroyalty in Peru. All right, let's talk a little bit about mineral deposits in the Andes, because Potosí doesn't exist except there's some way to make silver, and as we'll see later, other ore deposits. So you see here, this is the Andes, and we're here in Peru, there's Bolivia, Argentina, Chile, and there's the Altiplano, and then the Andes are broken up into the Eastern Cordillera, the Andean Cordillera, and the Pre-Cordillera, and things like that. And there are mineral belts that go across here in a systematic way, we'll see in a minute. So here's the Altiplano, and Potosí is down here. You know, we'll talk more about these salars when we talk about lithium later. There's Arica. So the mining was here, and it was brought down to Arica. Let's talk a little bit about Bolivia while we're here. It is a little over 1 million square kilometers, which is roughly twice the size of Texas. It has 11.5 million residents, whereas Texas has pretty close to 30 million now. And its per capita GDP, $3,800 a year, is about 1/10 of that of the U.S. per capita GDP at $34,000. And there's Potosí in the country of Bolivia. All right, so Bolivia lies in what's called, the Potosí lies in what's called the Bolivian Tin Belt. So here we can see there's several mineral deposit belts here, and this is the Tin Belt over here, the easternmost one of these mineral belts. We'll be talking more about the Copper Belt in Chile later, but these several belts, you know, we got 4 of them, 5 of them here. The iron belt, copper moly gold belt, copper lead zinc silver belt, copper iron belt, and the tin belt. So here's the tin belt, and there is Potosí. The igneous intrusion that made the Potosí silver deposit formed pretty recently, only about 14 million years ago. So remember, we have a subduction zone, and the Nazca Plate is being subducted underneath western South America, and that's causing the Andes and the igneous activity in it. And here we see the belts. Here's the copper belt, here's the copper, lead, zinc, silver belt, and here's the tin belt, and that's where Potosí is. And this reflects, these different mineralization zones reflect the different fluids that are coming off the subducted oceanic lithosphere. We don't need to worry too much about that, but there's a systematic nature to mineralization that we see here. All right, so Potosí formed in a caldera, and here is an example of how that happened. So what happens with a caldera is you have a magma chamber at depth, magmas come out of it, sometimes explosively, volcano builds up above it. Sometimes a lot of magma comes out of the magma chamber, and a big eruption will remove a lot of material from this, which allows this region to collapse. So as that collapse goes on, there's bigger eruptions, and so you get this dropping down of the crust into it. And then after everything settles down, you've got a big hole in the ground where the volcano used to be, and then some fluids will come in and come up some of these faults, and they may have silver or other ore deposit, and they'll deposit these to be, you know, once erosion cuts down into the crust, then people are able to exploit these deposits. And then the cycle begins again. All right, so mineralization, the deposition of the silver in these calderas is related to the circulation of water around the cooling magmatic intrusion. So here you've got very hot magma down here, and here you have maybe a lake or something, and the water sinks down, interacts with the rocks, carries a lot of material dissolved in it back towards the surface after it's heated up, and deposits it maybe in cracks or something for silver. Now, we know hot springs very well because we enjoy them. This is one in California called Mammoth Hot Springs. It's an active volcanic field, and here you can see the water gets in, and then the water heats up and comes back up. There may very well be mineral deposits underneath this, but we won't know until erosion cuts down and exposes the rocks. All right, so when hot water and steam reaches the surface, they can cause things like fumaroles. You know, this is a fumarole here. Hot springs, you know, there's a hot spring. Mud pots, there's a big bubble of mud there. And other interesting phenomena. And we're going to talk more about what happens with hot water when we talk about geothermal energy in a couple of lectures. So we'll come back to this interesting thing. All right, now in addition, that, as we said, this circulation of water and heating up by the magma, and it allows it to pick up things, and these may be deposited in an ore deposit up there. And that's underneath the ground, and that's what happened to make the Potosí deposit. So here we have a geologic cross-section of Cerro Rico. So this is a little volcano on the edge of this big caldera here. And then we can see lots of other rocks in here, but these are very old rocks, these Ordovician ones. They're 400 million years old. The rest of these are quite young volcanic rocks, as we talked about, maybe about 15 million years old. So here we have the geology of southwestern Bolivia. So we're this region down here, right at the border with Chile, and Peru up here. And what we can see here are some of these very old rocks in green. They're sort of there in the being deformed by the Andes mountain building. And then a lot of young sedimentary rocks here in yellow around the lakes and the salars. And then these young volcanic rocks in pink showing you where the volcanism was. And then Potosí is right here on the margin of one of these big volcanic fields. All right, so Potosí is a mineralized dome, and a volcanic dome is squeezed up in as viscous magma. It actually makes kind of a blister, and there may be some small eruptions with it. But in addition, you can find places where there's mineral deposits. And here you're seeing examples of different kinds of mineralization associated with volcanic domes. Here we see dikes associated with Cerro Rico, and then there are other kinds of deposits in there too. We don't need to get into big detail about that. Okay, here we're zooming in on the mineralized veins of silver in Cerro Rico de Potosí. So this is the elevation in meters, so 4,800 meters down to 4,200 meters. Here we got these old rocks, these 400 million year old shales and sandstones, and then the volcanic successions in here, and then this is the big mineralized dome of Cerro Rico dacite. All right, so here we have Cerro Potosí, so the town down here, the dome up there, and here's an example of a couple of guys getting something out of one of the mine shafts. So remember we talked previously about the difference between oxide ores and sulfide ores. That oxide ores were easier to turn into metal because you only had to do one reaction, and sulfide ores are more difficult because you have to do two reactions. But in general, when people find a deposit, they work this oxide zone, sometimes called a gosen, and then they'll keep going into the sulfide zone, the main ore body. And these gosens form where oxygen-rich waters interact with and oxidize the original sulfides. So the sulfides are there first, and then erosion cuts down and exposes the sulfides, and interaction with fluids and air oxidizes them. Gosens are rich, but they're thin. So for Potosí, it had gosen with somewhere between 4 and 25% silver. That's really rich. All right, now we talked about the huayrachinas or guairas for smelting in previous lectures. And this is an account of that by a Spanish in 1549. He said, the Indians made certain molds of clay in the shape of a flower pot in Spain with many air holes, and then charcoal was put into these molds with ore on top of that, and then they were placed on the part of the hill where the wind blew the strongest. That's what you're seeing here with these 3 huayrachinas, 2 of them with smoke coming out of it being tended by people. The metal was extracted. You can see the metal coming out here, which was then purified and refined with the small bellows. The Indians go to the heights with the ores to extract silver, and they called the molds guairas, or huayras. In the night, there are so many of them on all parts of the hill that it looks like an illumination. That was really something to see the hillside lit up with all of these huayras on doing what they do. So, now this is a report by Mary Van Buren from Colorado State much more recently, where she witnessed a modern Bolivian using a guaira, and it was for lead ore. And she says, the process I witnessed involved layering lead ore and carbon in the single chamber huayrachina, igniting it from below with burrow dung and grass, and then smelting it during a very windy afternoon so the oxygen penetrated the charge. The pure lead produced from the process was then used to create a lead bath in a different furnace in which silver ore was smelted. The main difference between this process and the ones used by the Incas is that only lead is smelted now in the Huayrachina, whereas in earlier times silver ores were smelted and then refined in a second furnace. So here you have an example. So Huayrachina in Bolivia. So Huayra means wind in Quechua, and China means the place of, or place that uses. So Huayrachina means place that uses wind. All right, so what we see with the production of silver, with the records that we have only go back to 1550, so the Guayra process could only reach temperatures that could smelt oxide ores. So it couldn't do anything with the deeper sulfide ores. And so these oxide ores were quickly depleted through the middle of the 1500s. So that by 1570, it looked like silver production was essentially going to go away. And of course, the environmental impact of having all of this burning was that the trees were stripped off the landscape. It was deforested. And we really don't know how much vegetation there was around Potosí at that time, but that was definitely an environmental impact. So today, Potosí is very dry and very little vegetation. You can see it here and here, that it looks like you're out in the desert. You are in the desert, but it's a high desert at 15,000 feet. And here's an image of the region taken from Landsat. So this is a satellite that orbits the Earth taking images of the ground. So here we can see Cerro Rico is over here, and the geology looks very inhospitable, almost like on another planet. All right, let's talk a little bit more about the climate of Potosí so you get a sense of how difficult it was to work here, which will contrast with what it was like to live in Guanajuato. But Potosí is situated in cold terrain. This is by Spanish, which receives much snow, is sterile and unproductive, and almost uninhabitable because of its climate. Almost uninhabitable except that it's the largest city in the world at this time. It is dry and cold and exceedingly windy, especially in summer when strong winds come up. They are violent and bring so much dust and sand that they darken the air. The rains begin in November and end in March. Nothing in the way of food can be grown except some potatoes because of the cold. The land is naked without trees or greenery. So you get a sense of how much effort must have gone into providing food for all of the workers in this largest city. This gives you a sense of what their life was like. Basically hauling the ore out on their backs. All right, now we mentioned the Mita when we were talking about the Inca, and the Spanish obviously had a desire to put the Indians to work to get the silver out for them. So they basically adapted the Mita concept from the Incas, and the districts in the region were required to provide workers for a period of about 6 months every 7 years. So something like military service, but very hard work. There were 12,000 mitayos worked in the Potosí mine. There were 40,000 deaths a year from a wide range of things. Mercury poisoning, we'll talk more about that. Mining accidents, you can imagine these things collapsed, or even if the shafts didn't collapse completely, rocks would have fallen on people and killed them. Malnutrition was a very serious challenge up there. And the European diseases, which came over from the old world with the Spanish. So the encomienda concept was another way that the Spanish forced the Indians to work. This was a Spanish labor system that rewarded the conquerors with the labor of the conquered non-Christian people. encomenderos were responsible for the economic development of the region, as well as were responsible for Christianizing, civilizing, and protecting Indians. And the mita and encomiendas were similar in many ways. But obviously where the Incas had once been, the mita was something easier to adapt than the encomienda. All right, now things changed in the mid-1570s when a new technology for extracting silver let the Spanish mine the sulfides. So this is called the patio process, which sounds rather pleasant, you know, sit out on your patio and have a beer or something. But it's basically an amalgamation, and the amalgamation is with mercury. So mercury is an amalgam that combines with silver and gold. Many of us have mercury amalgam fillings that we got from the dentist. And it will extract gold and silver from both sulfide and oxide facies. So it allows the sulfide ores to be profitably exploited. It was invented in Mexico in 1570 and was introduced in Potosí by 1573, when the production of silver was really declining rapidly. So what you had to do was you had to crush the ore and mix that crushed ore with mercury. And as you know, mercury is a liquid at room temperatures. And as a result of that mixture, the mercury amalgamates with the gold and silver, and then it sinks to the bottom of the thing and can be recovered. And then you get the silver by roasting the amalgam, which drives off the silver, and those mercury vapors can be condensed and recovered for reuse. So a large fraction of the mercury can be reused. All right, so where to get mercury? So the nearest source was 1,000 kilometers away to this region up here. And in addition, it was shipped in from Spain and Slovenia. You know, the ships were coming into Arica to take the silver, and they could also give mercury for the llamas to take back to Potosí. All right, so we can see the incredible growth of silver production with the introduction of the patio process. So in the 1500s up until about 1573, the decline in silver production was so large that you had to wonder if they were going to have to stop. But with the introduction of the patio process, so that the sulfide ores could be mined, the production of silver went up from a little more than 10 to almost 100, almost increased it an order of magnitude. And then the decline was significant, but sort of took most of the rest of the 1500s and 1600s before the silver mines were pretty much played out. So here's the patio process. This is a sketch, and we've got all of the ore down here and the amalgams on top, and then this horse is just going in circles, and that wheel is crushing the ore, making it better for the mercury to wet so it could combine with the silver in the metals. And that technology evolved to water-powered mills. And so by 1576 in Potosí, there were 22 human-powered mills, 15 animal-powered mills, and 18 water-powered mills at Potosí. And you can see a water-powered mill and all of the people down here working on the patio process. All right. So with time, it became clear the most effective way to do this was to have what's called stamping mills, where you just have big things come up and go like that to the rocks. And these had to be powered by water, and they built reservoirs to provide the water up there. There were 32 dams that were built, and there's 20 of them that are still being used. And one of these collapsed in 1626, and it killed 4,000 people and destroyed 125 mills. So, now the crushed ore is called the harina, and that harina was sifted and mixed with mercury in big vats or cajones. So the recipe was 5,000 pounds of harina and 600 to 1,000 pounds of mercury. That's a lot of mercury. 6 to 25 days later, the amalgam would be 80% mercury and 20% silver. It would be recovered from the cajones and placed in molds. And then it was placed in ovens for roasting. So here you can see the amalgam would be there, and then the mercury vapor would mostly condense against the sides, but certainly a lot of it would get out as well. So you could collect that mercury, use it over. All right, so let's move on to Mexico. Mexico is about almost 2 million square kilometers, or about 3 times the size of Texas, more than 127 million people, and the per capita income is close to $10,000 a year. So now we want to talk about the Mexico Silver Belt, and this silver belt runs about 1,000 kilometers northwest of Mexico City to almost to the U.S. border. So there's Mexico City, and that's the silver belt. All right, so let's talk about the silver of Guanajuato up here in Mexico. Now there's many other silver mines, but I don't think any of them in Mexico are more famous than the one at Guanajuato. So it began in 1548, and the Great Mother Lode, or the Veda Madre, was discovered in 1550, and this vein is remarkable. It's 15 miles long, and it's up to 650 feet wide. 35,000 tons of silver and 175 tons of gold have been produced out of Guanajuato by 1990. And these mines are still active. And the city of Guanajuato was founded in 1554. So here we've got a view of a Colonial silver processing plant at Guanajuato. You can already see that this looks like a more pleasant environment than Potosí, because you can see trees, right? But this is sort of the factory for extracting the silver. All right, so just to remind you, Guanajuato is not only a city, it's also a state. So Guanajuato is this one, and then all of the other states of Mexico, we don't have to memorize them now, but there are many. This is a geologic map, simplified, of Mexico, and we'll talk about the Sierra Madre Occidental, the western Sierra Madre, and the Sierra Madre Oriental, the eastern Sierra Madre, later in this class. But in between them is the Mesa Central, and that's where Guanajuato is, here in the Mesa Central. So, Guanajuato State is, as you saw, located in central Mexico, in the southern part of the Mexican High Plateau. It has an area of about 30,000 square kilometers. It's only 1.5% of the total area of Mexico, but a population of about 5 million, which is about 5% of Mexico's population. Guanajuato lies at about 2,000 meters, so 6,000 feet above the sea level, not 15,000 like Potosí. So it's a much more pleasant climate, as you can see. So during the colonial era, Guanajuato was fabulously wealthy from mining. From the 16th through the 18th century, Guanajuato was one of Mexico's most important colonial cities, along with some others. And some of the world-famous mines in Guanajuato, La Valenciana, Mineral de Cata, and Mineral de Reyes. And with this immense wealth came elaborate architecture, including many churches and mansions. And in 1989, in recognition of this historical importance, it was declared a World Heritage Zone by the United Nations. So here's a view of it. Here's another view. This is the University of Guanajuato. UTD used to have that university as a sort of a partner university. Next slide. All right, now here's the geology of what is associated with the mineralization. So what we're looking at here is what geologists call a stratigraphic column. It tells you the sequence of rocks that are in the area. So these are the older rocks. These are about 200 million years old, and then rocks about 50 million years old signal the establishment of a kind of river environment with conglomerates and gravels. And then we start seeing volcanics appearing about 35 million years ago with volcanic lavas and explosive facies of different kinds. We don't need to get into too much detail about that. But this upper part of the section is the volcanics that are related to the Guanajuato mineralization. This is older than the Potosí. Remember, Potosí was about 14 million years ago. This was formed about 35 million years ago. But they're both pretty young. All right, so here we've got a complicated geologic map. What I want to draw your attention to is not all of these units over here, not that they're not interesting, but the size of the Veta Madre. This is the Veta Madre. It is, now that is 4 kilometers. This is a monster. And so when they found that, all they basically had to do was get somebody to get the silver out and then go to the bank every day. Now, if we look, geologists like to make cross sections of things, and here we see a cross section from west-southwest to east-southeast, maybe 15 kilometers along distance, and then we're looking about a kilometer deep in the earth. And you can see that there's a bunch of faults that offset units. This unit has been offset from this one from that one. These are we call these normal faults. We don't need to worry too much about that. But the thing I want to draw your attention to is that the Veta Madre intruded one of these faults. And that's what controlled where that vein went. So here we're just looking at a cross-section of the Veta Madre. And remember, we talked about this being a mineralized zone in a west-dipping fault. So here we're looking from 2,000 meters down to 1,700, so 300 meters you've got this ore in here, and in places, the vein is tens of meters across, and you can see it's, this is very well behaved. It's there's probably more of it down here, right? If it's feasible to get down there, right? Probably just keeps going down. And basically, as we said, these hydrothermal systems that we talked about earlier with water interacting with hot magma and then dissolving things, and it probably came up this fault, and that's why the mineralization is along this fault. All right, here's an old drawing of what the mine looked like. Obviously, you're going to have a big shaft in a vein that big. There's just so much ore. All right, let's talk a little bit about the Valenciana mine, which was located on a bluff overlooking the city. It was where the Veta Madre was discovered in 1558, and it was easy to follow that inclined zone, mineralized zone, down at least 750 feet. And then once they knew what it was doing, they said, well, let's just dig vertically. And so they did that in 1791 to intersect the mineralized zone at depth. And the peak production was 58 tons of silver in 1797. So let's talk about the silver coming from New Spain, Mexico, versus the silver coming from Peru. So between 1570 and 1650, about 25% of all the colonial silver was produced. And of that, more than 60% of it was produced in Peru. And of that, more than 50% was produced in Potosí. So in the last half of the 17th century, the Peru silver production started to decrease, and the Mexican silver started to increase. And today, Mexico is the largest producer of silver in the world, with about 15% of the world's total, and Bolivia is not even in the top 6 anymore. Peru is actually in second place with 12%. All right, so that's kind of the history of how important this resource was to the Spanish Empire. But there's a headache that comes from that. So all of this mercury that was being used, a lot of it got into the environment. And mercury is a serious environmental problem in Mexico. It causes a range of health problems. It's estimated that Spain sent as much as 45,000 tons of mercury to Mexico during the colonial period. And there's still millions of kilograms that are beneath the soil in dozens of colonial mining sites, polluting groundwater and fields. And all of these red dots show major sites of mercury pollution in Mexico. Okay, that's it for that lecture. The next lecture will be post-colonial mining and development, the Chilean example.